Alright guys, this is standard 5. This is a reassessment on forces and circular motion. So I chose question 18 of chapter 5, and the question states, a 0.700 kilogram ball is on the end of a rope that is 1.30 meters in length. The ball and rope are attached to a pole, and the entire apparatus, including the pole, rotates about the pole's symmetry axis, meaning that it rotates around the ball like a tether ball. The rope makes an angle of 70 degrees with respect to the vertical axis. What is the tangential speed of the ball? So here is the image that they provide you in the book. My free body diagram looks something similar like this. It's got tension going up and to the left with the theta, and a force of mass times gravity going down. My known values are mass, which is 0.700 kilograms, and theta, which is 70 degrees. And here is how I proceed to solve the problem. So I use Newton's second law, and I find the forces in the x direction, which is just t sine theta, which is also equal to m times v squared over r. And then I find my forces in the y direction, which is t cosine theta minus mg, mass times gravity. I then proceed to find my t value, so I set t cosine theta minus mg equals 0, and then I add mg to both sides, which gives me t cosine theta equals mg. I then divide both sides by cosine theta, which gives me t is equal to mg cosine theta. From here, what I do is I end up plugging in my mg cosine theta into my t of my x direction, which gives me m times v squared over r, which is equal to mg over cosine theta times sine theta. This is the t value that I found from my forces in the y direction. From here, I then you can just combine them, multiply the top values together, which is sine theta times mg over cosine theta, which gives me this right here. So sine theta and cosine theta are pretty much tangent theta. So I rewrite the equation as mg tangent theta. From here, my m's can cancel out, and I get v squared over r is equal to g times tangent theta. And then I can multiply both sides by r, which would give me v squared equals the rg tangent theta, and then I can square this to get rid of the square value and just give me v, and then it will square this value. So my final formula would be v is equal to rg tangent theta. So from here, we don't have our r value yet, so what I do is I multiply the 1.30 meters, which is the length of the rope, times cosine of 20. I'm using cosine of 20 because the pole is going up and down, meaning that it's at a 90-degree angle. So being that the angle is 70 degrees, you know that the reference angle you should use is 20 degrees. So then multiplying that gives me 1.22 meters. And then I just plug in everything into the formula, which ends up giving me 5.71 meters per second.